Today we're working on elimination. We've done substitution for a couple days, and that's one way to solve linear equations. And elimination is usually easier, except when it's not, and then it can be quite a bit harder. So if I had 2x minus 3y equals 12, let's do 4. And then 6x plus 4y equals, I don't know, -4. So what I have here are two lines. They're set up in equations, and each equation is a sort of balance. There's just as much weight on the left side as there is on the right side. We don't know what x and y are, but the top equation has 12 pounds on the right and on the left, and then the bottom equation has -4 pounds on the right and the left, which is a little bit weird. So if I took two equal things and then I combined them with two other equal things, I would have a new set of equal things. Does that make sense? And in this case, it makes a lot of sense to add them together because the y's cancel each other. They eliminate. So the x's would give me 8x. Oh, what are the chances? That was such a good guess. 8x equals 8. So we divide by 8, and x is equal to 1. How do I find out what y is? Plug it in. Does it matter what equation I plug it into? No, it doesn't matter. So I'll stick it in there. 6 times 1 is 6, plus 4y equals -4. Subtract 6, and I get 4y equals 10. Divide by 4, and y is equal to 5 halves, so 2.5. Does that make sense? Now, elimination is really easy when the variables are set up in such a way that they do eliminate. So look at number 1. Well, let's not do 1. Let's do number 4 on your worksheet. So the x's are set up for elimination. Same value, different signs. Those cancel, and I get 9y equals -9. So y is equal to -1. Then I plug that back in. 6x minus 4 equals -10. Add, add 4, and I get 6x is equal to -12. Divide by 6, and x is 2. Easy enough, right? Okay. This is not on your worksheet, by the way. Can I eliminate here? Not in its current form. If I were to add the two equations together, then I will still have x's and y's. So what can I do to this equation to set it up for elimination? If I tripled the bottom, then the y's would cancel. So I'm going to multiply this by 3. And I get 6x plus 3y, and then that's, so 3 times 20 would be 60, so 57. Now my y's will eliminate. 9x equals 90. So x is 10. Then I plug that 10 into one of the equations. 20 plus y equals 19. Subtract 20, and I get y equals -1. Any questions there? All right. Look at number 20. How am I going to eliminate this one? Yeah, there is no whole number that I can multiply either the top or bottom by to eliminate the x's or the y's. So you're going to have to multiply both of them. So we multiply the top by something and we multiply the bottom by something. Should I eliminate the x's or the y's? It doesn't matter in this case. They're both the same difficulty. So let's say I want to eliminate those. What do I need to multiply the 3x by? 5. So if I multiply this one by 5, and then the bottom one I need to multiply -3, because I want those 15s to be opposites. So -3, and that creates two new equations. 15x minus 10y equals 10, and -15x plus 15y equals -30. Any questions there? Now the x's go away. The y's would be 5y is equal to 20, -20. So y is -4. Then you plug that in. 5x plus 20 equals 10. Subtract 20, and I get -10 divided by 5 is -2. So what does -2, -4 tell me? When I say that's the answer, what does that mean? What are we looking for here? That is the point where those two lines intersect. And it's the only point that works in both equations. So if I plug in -2 and -4, then the left side will equal 2. And if I plug in -2 and -4, then the left side will equal 10. And that is the only point that works in both equations. There are lots of points that work in the first equation and lots of points that work in the second equation, but there's only one that works in both of them. Okay. Well, sometimes we get an answer that's a little bit different. Oh, 2y. How am I going to set this up for elimination? So we'll double the bottom, and we get -2x plus 4y equals 12. And what happens? Zero equals -4. What does that mean? There is no point that works in both equations because they don't intersect because the lines are parallel. Does that make sense? And if you look carefully, you'll notice that those are actually the same equation with different answers. So if you double the bottom, then the left side, or if you times the bottom by -2, then the left sides are equal and the right sides are not equal. So if I change this to a -4, now when I double the bottom, I'm going to get -2x plus 4y is equal to -8. And when I add those together, I get 0 equals 0, which means it's the exact same line graphed twice. Where do they intersect? Everywhere. All right, any point that works in the top equation is also going to work in the bottom equation. All right, any questions? I'll put the answers up on the board. Get to work.